Students, friends of BSc 6th semester, I'm here to discuss a bit of operators and expressions, the last part of this topic known as operators and expression. So far we have discussed arithmetic operators, increment and decrement operator. Today we'll discuss the remaining operators. Since this is the upcoming examination is multiple choice question mode examination, so we cannot leave out any bit of a syllabus here without discussing. So relational operators. Relational operators. These relational operators, they are used to compare the two operands, two values given in an expression. These relational operations or operators define relationship exist between, say, two constants or variables. That means a relational operator, we can relate relational operator using relational operator, we can relate two variables or two constant, and we define the relationship between them. Result of this relational operators is to give a result of a relational expression using relational operator. There will be one or two operands or values. The result will be either it is true or false. There are 6 relational operators. Yesterday we have stopped here, and let me take these 6 relational operators. I'll write here operators. So less than, its meaning is less than, I need not write. I'll write here precedence, P-R-E-C-E-D-E-N-C-E, precedence, and associativity, how it is evaluated. Less than, its precedence is 1, priority, say left to right. This is, we have less than or equal to, and this is its symbol. The meaning is, you know, because we are using this operators, less than or equal to, greater than or equal to, or equal to, not equal to. Okay, so this less than or equal to is precedence, priority is 1, and again it is left to right, L to R. So greater than, this priority or the precedence is 1 and it is left to right. Greater than or equal to, we write like this, greater than or equal to, that is its precedence is 1, left to right, R. Equal to, this priority is second, that is left to right, again. Not equal to, that is this equal and exclamatory mark. This is the symbol of, say, not equal to. I'll write here the meaning, not equal to, not equal to. In each will this one we write this not equal to. Here it is equal to, say A equal to B, we write thus, that is equal to. Its precedence here not equal to is 2, and again it is left to right. All these operators are evaluated from left to right. So there are 4 operators. They have the first priority in an expression called as relational expression. In C language, if there is a relational expression of this operators using the constants or variables, I have written here this is relational expression, or I can write A greater than B if A is 3 and say A equals 3 and say B equals say 2. This is true. A is greater than B. A is 3, 3 is greater than 2. It's true. The result will be either it is true or false. Now I'll give some examples here. These are the operators, 6 operators, and the priority, first 4 will have the first priority, the second 2 will have the second priority. Say here, I'll write A greater than B. Okay, X equal to Y. Say number, some number not equal to 100. It is not equal to 100. I'll say write salary. This equal to say 10,000. You need not write, or this is 10,000. You need not write comma here. It is not allowed. In usual usage we use it, but here it is not allowed. Since salary may be a floating point number. Floating point number. That means these relational operators can be operated integers as well as on floating point numbers or variables, constants and variables. Let us take one example here, how it works. Say I'll write A, say B, A equal to, assume A is equal to 2, B is equal to 3 and say C is equal to 1. These are integer, constants are integer variable. At a given instant they have these values. Now if I write the expression called as relational expression A greater than B. Now look at this, A is 2 and B is 3. We cannot say it is true. Here the explanation for this or the result for this is false. It's not true, it's false, because 2 is not greater than 3. When the constant A or integer A takes the value here in the program, so when we write this A greater than B, and when A is equal to 2 and say B is equal to 2, we can't say that 2 is greater than 3. So the result will be false. And its value, when we say it is false, its value will be 0. True, its value will be equal to 1. So its value is here 1. Expression, interpretation and value. This is one example. Let me write using this, say A plus B addition is less than C. This is an expression called as relational expression. When I substitute or when computer accepts as an input, say A is equal to 2, B is equal to 3 or C is equal to 1, our computer can initialize, we can store the values of these variables in the memory. So when it is executing this expression called as relational expression, it will say, what is the interpretation of this? The result is false because A is equal to 2, B is equal to 3. We have the arithmetic addition. 2 plus 3 is 5, which is less than C, where C is equal to 1. The answer is false here. And the value is here 0. False means 0, true means 1. I can write using this. Say B is greater than C. B is greater than C. Look at the value of B. B is 3 and C is 1. Result is true and the value here is 1. If I write using this operator equal to, say, C equal to 1. And it is true. Here it is C is equal to 1 and the value is 1. So this X gives us an idea about what is called as relational operator. Fine. There you can write some programs also. Since we have a shortage of time, let us go for other type of operators. What is called as logical operators. Logical operators. Fine. In C language, logical operator is a class of C language. Logical operators is a class of C operators, and these logical operators are used to take the decision or to make the decision. And there are three such logical operators. The AND, it should be written in capital. Hope you are familiar with this because in 6th semester paper 2 you are studying this in logical or Boolean algebra, logical gates and other things. Hope it is covered. This is OR and say NOT. And they are called as basic Boolean operators. Basic Boolean operators, and they are used in Boolean algebra. Right? So our aim is to learn all the types of operators which are available, use them in C and make this language rich. So at the beginning itself, I have mentioned that C language is having rich set of operators. Rich set of operators. We are not only using arithmetic operators, we are using decrement, increment operators, we are using relational operators, we are using logical operators, we are using bitwise operators, we are using special operators, we are using conditional operators and so on. So logical operators AND, OR and NOT. These operators, they use two binary operators, that is 0 and 1. Binary operators, you can say, or the first one, the AND, use this bits 0 and 1. The second one use this bit 0 and 1. They are called as binary operators. And NOT is, logical NOT is unary operator. When we have started this topic, I have mentioned this and I am taking now this. That is logical NOT. Logical AND, logical OR and logical NOT. Logical NOT is unary operator, whereas AND and OR are binary operators. The result will be same as the relational operator, that is false or true. You can say false or true. Right? False means 0, true means once. These operators, they have definite symbols in C language. That is, symbols in the sense we are using of the character set to indicate, to denote these operators. I'll write here operator, and say operator is this amperes and, it is double amperes and. I'll write double amperes and. Amperes and the meaning of this is logical and. Very soon you are learning about this in practicals. Hope this has been covered in number system, Boolean algebra. Hope so. And its priority is 2. Its precedence is 2. It will be evaluated left to right as it were. It will be evaluated from left to right. That is called as associativity. This is called as precedence. This is its meaning, logical and this is the symbol used here. This is pipeline character. All these are the characters of C. Double pipeline here. Double pipeline. And this is logical OR. And this is priorities 3. That means if they comes together, first will be operated, lesser the number, more is the priority here. Larger the number here, it will be operated little late, right? So this is again evaluated from left to right. Fine. Then we have this exclamatory mark, exclamation, EX, C, exclamation, and this is unary operator, logical not, and this is priority is 1, precedence is 1, operated left to right. These are logical operators. Okay. Now this logical operators, they have this, what is called as and, or, and not. In fact, and, or, and not are the basic operations of Boolean algebra. They are called as operators, and when we operate them, right, that anding, oring, or negating, or inverting, or complementing. So they have the truth table. Truth table of this AND gate. I'll write it here. Truth table of AND gate, or sorry, AND operation, not gate here. AND operation. This is say input A and B, or say operand. Here in C language we will write operand 1, operand 2, that is value, and then operand 1 and 2, that is say ANDing. Okay. So false means 0, false, it will be false. Say false, true, that is 1, it will be false. True, false, it will be false. True, 1, 1, it will be 1. This ANDing operation or AND logical operator will have the value true provided both operands, both values will be true. It is nothing but multiplication. And this it follows this truth table. Similarly, we have for OR operation. OR operation 0, 0, OR is double pipeline. ORing. I'll write here ORing the output. You can write 0, 0, 0. Say 0, 1, 1, 1, 0. It is 0, 1, 1. It is 1. It will not be 2. It is 1. Logical 1. This is truth table of what is called as OR. This is 1, 0. It is 1 here. Sorry. It is 1. Okay. And OR operation, we have what is called as, say, NOT. NOT. Logical NOT is unary. Logical NOT is a unary operator. So operand false, you can say it is 0, output is 1. Say 1, 0. This will work as inverter. This will work as inverter. If input is 0, the output will be 1. If input is 1, output will be 0. It works as an inverter or vice versa. We can use them for a logical expression. Evaluation of logical expression. Evaluation of logical expression. Fine. So I can write some expressions here and then we'll see how it works. If I have the variables or integers a, say b and c. Fine. A, B, C. A is equal to say 2. It is integer value. B is equal to say 4 and say C is equal to 3. These are the values. I will write what is called as logical expression. C language logical expression. Say here variable A. Fine. Okay, I'll write here variable A. It is amperes and, that is logical and, a variable B, then logical or, the variable C or constant C, and amperes and, say here it is not B, not B. This is expression called as logical expression. C language expression, and we have written using logical operators, so it forms a logical expression. When we have used arithmetic operators, we called it as arithmetic expression. We are writing logical expression using C language. Using C language here. Say A, they may give this for a multiple choice. A and B, that is C, say amperes and, that is anding, this is ORing. Okay, so it is same as upper one. Let us see. Let us evaluate this. We have written this. Okay, fine, both upper and this is 1. Let me substitute the values for A is equal to 2, B is equal to 4, C is equal to 3. This will be equal to A is 2, this operator, AND operator, logical operator, B is 4, this is logical OR operator, and C is 3, AND operator, and this is not, right, it is 4. Now, how it is evaluated? See, not 4 is true, so its value is 0. That means B is not operated, B is not 4, so it is false, and it is B equal to 4 it is false, so the output here, or what is called as output of after operating this operator on a variable or a constant c, it is 0, false. I'll write 2, this is ANDing, 4, thus, 3, thus. Hope you got thus. Okay, now. So this is 2 and 4. This is ANDing operation. It is multiplication. So A is 2, B is 4. Right? And it is true. So we'll write the value 1 here. And this is OR operation. Okay. That is 3. 3 is ANDed with 0. And this is 0. Okay, it is multiplication. This will be 0, 1. That is 0. This is OR. Or if you look at the logical or a truth table of OR operation, it will 1, 0 is 1. This is the output of this logical expression. Operator of logical expression is given and its output here. Evaluate the logical C expression. If they give the question, you must be able to answer this. There is another kind of operators called as bitwise operators. Let me see, what is the time? 5. Bitwise operators. Bitwise operators. I've mentioned them here. See, in machine, that is whichever may be the machine, here a computer machine, all the data are stored in the computer's memory as a sequence of zeros and one. I have told this in machine level language, or sometimes we have to manipulate this data which are stored in the form of sequences of zeros and 1. To manipulate that data, either we are using a machine level language or assembly level language. To perform this bitwise operators or bitwise operation, C language provides 6 bitwise operators. These bitwise operators, they cannot be operated on integer, float and character type data. Bitwise operators can operate only, this can be asked for objective. Say bitwise operators can operate say a integer, can operate say, or cannot operate, you can say, we cannot operate integer, say b, char, say c, float, say none of this, d, none of this. Okay, none of this. Fine, these are the 4. So these bitwise operators cannot operate on a float, and this will be answered here. They can operate on integer data, they can be operated on character type data, or that can be, here you can write string data, string. But string is not a proper answer here, that is none of this is correct, none of this is correct. Okay, so we can frame a question. A bitwise operator cannot operate integer. It can operate character type data. It cannot operate float type. Means bitwise operators cannot be operated on real point number, floating point number. Hope you can remember this. And we have here, there are 6 operators, bitwise operators. I'll mention them here. This is operator. I don't think operator, symbol, say meaning. Fine. So this is only amperes and this meaning is amperes. The operator symbol amperes and meaning is bitwise and pipeline single. So this is pipeline. Bitwise or caret. This is exclusive or XOR, and this is one of the gate, AND gate, OR gate, exclusive OR gate. Tilde, one's complement. This is again a Boolean algebra, right? One's complement. Hope you have learned this. Greater than, double, say less than, double, less than, left shifting. Sometimes you have to shift, left shifting. And greater than, double, greater than, right shifting. And these are say bitwise operators. They can be used to have the expression, bitwise expression. We have other expression, what is called as conditional expression. Conditional operators. We have conditional operators, and there are special operators. I just mentioned about the special operators and then complete this. C language provides some of the special operators, that is 1, comma is a special operator. Size of is a special operator. Address operator. Okay. Differentiating operator, dot operator, and arrow operator. These are some special operators we have in C language. Fine. Other than this, what we have, you can read about this. So you can list them. What you do is, I'll upload the notes of this. You can list them and remember them. They may be asked for objective type questions and easy to frame, and those who are unable to read or not preparing, they will miss the marks for this. There is another possibility of operating.